This is the video for Collision Lab. So this is our Canvas page, and you see in the lab file, we have Collision Lab. And you see there's elastic collision PDF, explosions, and inelastic collision. I want you to turn in all three assignments. Let's go to elastic collisions. So the part that you need to fill out is this section here. This section, this section, this section. So all these 9 parts that you need to fill out. Let's see what you're going to do for this lab. For elastic collision, either way, what I want you to do is to copy here, and let's see, let's go to Google. And this is the website that you do the simulation. And what I want you to do is to do the Lounge Interactive, plus here. And here you get to choose elastic collision, inelastic collision, and explosion. Since right now we have elastic collisions, so I want you to select this elastic collision here. Select it, and you could choose the mass of the red card and the blue card. I can choose 1 kilo and 1 kilo, and this is an elastic collision. The red card is approaching with the positive 5 meters per second, and the blue card is approaching with the negative -5 meters per second. And this negative means it's just moving in a opposite direction to the red card that's coming towards the blue. So blue is moving towards the red is moving towards blue. And let's see. So, before that, so you notice mass of the red card is going to be, this is going to be 1 kilogram, 5 meters per second, 5 kilogram meter per second. The blue one, in this case, is going to be 1 kilogram minus 5 kilograms. So therefore, this is going to be minus 5 kilogram meter per second. Then you do that. Then after that, you will see, and then you're going to find the system total. System total is going to be the momentum of red card plus momentum of the blue card. So that's what you're going to fill in. Same thing. After collision, you're going to run the simulation, and then you find out what's the mass doesn't change and what is the velocity and the momentum of red card, momentum of blue card in kilogram, and velocity. And then you find the total momentum, which is the momentum of red card plus the momentum of blue card after collision, after makes the elastic collision. So you can find the total just simply adding the 2 momentum here. And over here, I want you to just focus on the red card. Red card, if you focus only on the red card, the change in momentum, that's going to be the final momentum of a red card minus the initial momentum of the red card. So you write that down here too. It's going to be the final momentum of the blue card minus the initial momentum of the blue card before collision. It's going to be here. How about the change in momentum if you're looking at a system total, which is the red card plus the blue card? So you're going to see the total momentum after collision minus total momentum before collision. And you write down the difference in momentum. So that's what I want you to fill out. In this case, you get to choose whatever you like. You choose the mass to be 1 kilogram for the red card, blue card, or different. It could be 2 kilo and 1 kilo. You choose, write down what value you're using, and run the simulation. So 1 kilogram after collision, the red one has a minus 5 meter per second. After collision, the blue one has 5 meter per second. Like I said, it doesn't have to be 1 kilo and 1 kilo. We could also what's going on? Choose something like that. 3 kilogram, 1 kilogram. 2 kilogram, 1 kilogram. So you decide on the value, and the value you decided to use, make sure you record it. How much mass the red card is, and what's the initial velocity before collision. What's the mass of the red card after collision, and velocity of the red card after collision. So it's very straightforward. After that, oh, it has the, I apologize. You don't get to choose what you want to do. Sorry. Big apology. You always should read before you start. So collision one. First, I want you to have a blue card initially at rest. So blue card initially at rest. Initially at rest. And that red card is going to make elastic collision. And then you're going to see what it happens. Record the value after making elastic collision of the two. So 1 kilogram, 5 meter per second. This doesn't have to be 1 kilogram. You can choose 1 kilogram, 2 kilogram. You can have the mass of the blue card to be 1 kilogram or 2 kilogram. Initial blue card. Set the mass values to different values. So I want you to have 2 kilogram and 1 kilogram, or it could be 1 kilogram and a 3 kilogram. You can choose whatever you like and run the simulation and record the mass and the velocity value. So record all these values. Collision 2, blue card moving slower than a red card. So they're both moving in the same direction. Position the blue card near the red card so that the collision occurs near the mid-track. Give the smaller mass. Blue card, a smaller mass. So 2 and 3. Initial velocity. It says the blue card is moving slower. We can move it like here. Right? Set, start. Let's see what happens. So you write down the, after they make elastic collision, find out the total momentum before collision, after collision. Find out the change in momentum for the red card, change in momentum for the blue card, change in momentum for the total system. And you know that this has to be equals to. So that's for the elastic collision. And I want you to do the same thing for explosion, inelastic collision. Let's see. Inelastic collision. Initial blue card 0, mass different value. So I think it's very straightforward. I apologize. Just read the direction, decide on the value, write down the value that you choose to simulate, and record, take a measurement of the each after collision. And in this case, we are doing inelastic collision. So you want to choose inelastic collision. And similarly, you're going to do it for explosion for the different file. So that's it. This lab is pretty straightforward. And if you do have any questions, feel free to send me an email.